We're just going to get a little more practice today with classifying the numbers, putting them in the different groups. So not adding anything really new or completely new to it. All right, so I've got, was that 9 numbers up here on the board. For right now, just going to classify between rational and irrational. All right, so let's just start with go left on, work our way over. Just going to use the mouse because the board's still doing its thing. All right, square root of 35. Who can tell me where that goes? Is that rational or irrational? Who can raise their hand and tell me? Greg. Irrational is correct. Square roots that we don't know are going to be irrational numbers. They're going to be decimals that keep going without repeating. All right, square root of 49. Rational. We know that one's rational because that's the square root. No, what's the square root of 49? 7. All right, 1/7. JC. Rational. Our rational numbers are numbers that can be written as a fraction. So, obviously, the fraction is a rational number. Fractions can be written as fractions. All right, 4.76 with the 7 and 6 repeating. David? Nope. Greg? Rational. Repeating decimals. Repeating decimals are rational. If it is repeating, there is a way to write it as a fraction. At square root of 2. Zay. Irrational. Square root of 2 is one of those we don't know. 9.56 with some dots coming after it. Elena? It is irrational, yes. When it has the dots after it, the dots means that it keeps going without repeating. All right, so the dots means it keeps going without repeating. Those are going to be irrational. 8 and 5/9, a mixed number. Elena? Rational. Mixed numbers obviously have fractions, and we should be able to put them as improper fractions, make them a fraction. 3 pi. Irrational. If you see pi, pi is almost always going to be irrational. There are some exceptions I'll show you eventually, like where you got pi on top and bottom of a fraction. Negative square root of 16. Rational. What's the square root of 16? 4. So square root of 16 is 4. The negative in front of it doesn't really affect it. That just makes the whole thing negative. Negative 4 is still going to be rational. Okay? Anybody got any questions on those? All right, so this is what I was talking about. Y'all see this here? I got 3 pi over 4 pi. When we see pi, usually we think of pi as an irrational number. Pi keeps going forever and ever without repeating. However, in the case of something like this, where it looks like a fraction, if we've got pi on top and pi on the bottom, they actually will go ahead and cancel each other out. I can show it this way. If I have, let's go 3 times 2 and I was going to do the multiplying. I got 4, maybe. I got, well, not wanting to cooperate. We're just going to pretend that's going to say 4 times 2 on the bottom, okay? So if I got 3 times 2 on the top, 4 times 2 on the bottom, what's 3 times 2? 6. What's 4 times 2? 8. So I'd have 6 over 8 when I multiply that out, right? That's a fraction. When I go to simplify that, what number goes into both those? 2, right? So we would divide each of those by 2, and we're right back to 3/4 when we simplify it. That makes sense? So if I had it multiplied out, like over here, I could have just canceled out those 2's to start with. It's the same idea with pi. When we got times pi and times pi on the top and bottom, we can just cancel them out. That makes sense? So that would make this one rational. That's like the one time where if you see pi in it, it would be rational. Almost every other time you're going to see pi, you'll make the thing irrational. All right, so we got some fractions here, square roots and cube roots. With fractions, if the square root or cube root symbol is over the whole thing, we take the square root or the cube root of each part, the numerator and the denominator. If the square root or cube root symbol is over just one of those numbers, like you can see those bottom 2, then we just take that number. Okay? So this one on the top left, the square root symbol, we got a square root of 1/25. So we're going to take the square root of each part. Wilbert, what's the square root of 1? 1. Braxton, what's the square root of 25? 5. So when we take the square root of 1/25, that's going to be 1/5. We know both of those. So what that does, I'm just going to put an R, that's going to make that rational. Okay? Everybody kind of follow? All right, so we look down here. The cube root symbol on that one on the bottom left is only over the 27. The 7 doesn't have a symbol, so the 7 comes out by itself. What's the cube root of 27? David? 3. That's one we know, right? So I got 7 over 3. That's a fraction, isn't it? That makes this rational. Everybody kind of follow how that worked? All right, so we go to the top right. Cube root's over the whole thing. So I take the cube root of my numerator, cube root of my denominator. Who can tell me the cube root of 8? Cube root of 8. No. What's the cube root of 8? Zay? 2. 2 times 2 is 4. Times 2 again makes 8. So we got a 2 on top. What about the cube root of 36? Greg? 6? Cube root. So we got to do it 3 times, right? So if it was 6, 6 times 6 times 6, that's 216. So 6 won't work. Anybody got the cube root of 36? David? There isn't one. That's one of those we don't know, okay? I mean, we can figure out kind of a decimal for it. It's one that doesn't, it's not a perfect cube, okay? What that means is that makes the whole thing there irrational. Everybody follow on that? All right, bottom right then. The 9 just kind of stays as the denominator. Square root of 48. No square root of 48. 6 times 6 is 36. 7 times 7 is 49. It's pretty close to 7, but that's one of those we don't know an exact number for. So whole thing becomes irrational. Everybody kind of follow on that? All right, so a little trickier. Tell you what, give this a try to start with. We'll start that way. I need to know if that is rational or irrational. The product of the square root of 9 and 12. All right, you can tell me, is that rational or irrational? Zay? Nope. JC? I was going to say, you better get right if we get wrong once, right? All right, so this one is going to be rational. Here's why. Product. What does product mean we're doing? Multiplication. Product is the answer to a multiplication problem. Remember, sum is addition, difference is subtraction, quotient is division, and product is multiplication, okay? So that means we're multiplying here. Square root of 9 and 12. What's the square root of 9? 3. So I'm multiplying 3 times 12. 3 times 12 is 36. Is 36 rational? Yeah. So that's why that one's rational, okay? Basically, it comes down to, is that a square root we know, or is that not a square root we know? Right? All right, so we're going to work with some of these again, too. All right, so remember, we got square root of 18. I got square root of 56. I draw the lines just because that makes it stay a little more organized. Square root of 18. What two numbers is that in between? David? 4 and 5. Y'all, 4 squared would be 16. 5 squared would be 25. 18 goes in between each of those. So square root of 18 is somewhere between 4 and 5. Now we do the same thing with the square root of 56. So get which two numbers that is in between. Seven and 8 is correct. 7 squared is 49. 8 squared, 64. 56 is between those two. So square root of 56 is between 7 and 8. When we're looking for our sum of all the integers in between, we're going in between those two lines. That's where those two lines help. Y'all, what's missing? 6. We fill in any missing numbers, okay? Once we have them filled in, we're going to add them up. So, JC, what you got? 18 is correct. 5 plus 6 is 11. 11 plus 7 gives us that 18. Okay? Any questions on that one? What do I do first? If I'm trying to solve this for x, what should I do first? Blanca, what should I do first? Yeah, the 9. We're going to subtract 9. So we do opposite, so I go minus 9 from each side. So I've got x cubed, because my 9's cancel out on the left side. Didn't mean to move it, but we get the idea. 17 minus 9 is 8. So everybody okay with that step? If there's addition or subtraction, you get rid of addition or subtraction first, okay? Then, since I got x cubed, I am going to take the cube root of each side. What we're trying to do is cancel out that cubed, okay? And if you do something to one side, you do the same thing to the other. So cube root of x cubed is just x. What's the cube root of 8? 2. So we would get x equals 2. If the exponent was a 2 on the x, we would take square root. Since it's a 3, that's where we take cube root. Any questions on that one?